Assalamu alaikum friends, welcome to my YouTube channel. In today's video we will discuss concrete mix design, which is one of the most important topic in civil engineering. Concrete mix design plays a vital role in ensuring strength, durability and workability, making it important for all construction projects. Friends, whether you are a civil engineer student, site engineer, or construction professional, this video will help you master NMAX design concept. So stay tuned as we break down the concept step by step. So let's start. Concrete mix design by ACI. So friends, first we will discuss what is ACI. ACI stands for American Concrete Institute, which definition is American Concrete Institute. ACI is a globally recognized organization that develops standards, guidelines, and technical resources for concrete design, construction, and material to ensure quality and safety. As our topic is concrete mix design, so what is concrete? Concrete is a mixture of three different materials. Aggregates. In aggregates, there are two types of material: coarse aggregate and fine aggregate. Cement. Cement is used as a binding material, and water. Now, what is concrete mix design? Concrete mix design is the process of determining the proportions of ingredients, that is cement, water, aggregates, and admixtures, to achieve a concrete mix with desired properties like strength, durability, and workability for a specific construction purpose. So friends, what are the bases of concrete mix design by ACI? So friends, the ACI methods of concrete mix design depend on the absolute volume procedure, where the volume of each component is calculated. The method is suitable for normal and heavyweight concrete, having a maximum 28 days cylinder compressive strength of 45 MPa. What are the data required for concrete mix design? So the data which are required for concrete mix designs are: number 1, required 28 days compressive strength; number 2, workability of concrete, that is value of slum; number 3, maximum size of coarse aggregate; number 4, fineness modulus of fine aggregate, which is we take as 2.4, specific gravity of fine and coarse aggregate, and bulk density. So let's take an example. Let's suppose we have a compressive strength after 28 days of a concrete is 20 MPa. So we will use the following table given in ACI for finding average compressive strength of concrete. Let's see in the table that we have a compressive strength 20 to 35 MPa. So the average compressive strength will be FC dash plus 8.3 MPa. We have to add 20 MPa, which is the compressive strength, required compressive strength. We will add 8.3, so the average compressive strength will be 20 plus 8.3, that is 28.3 MPa. The second step was the workability of the concrete, that is the value of slum. So the value of slum will be given by the designer, and let's suppose in our case the slum value is 25 to 75 mm, that is 1 inch to 3 inch. So recommended slum value for different types of constructions are reinforced foundation, walls and footing. Maximum value is 75 mm, that is 3 inch, and minimum value is 25 mm, that is 1 inch. Plain footing and substructure walls 75 mm, 25 mm. beam and reinforced wall 100 mm, 25 mm, building columns 100 mm. The next step in the concrete mix design is to find the maximum size of aggregate. So friends, the maximum size of aggregate will affect the parameters such as cement paste content, workability and strength. In general, the maximum aggregate size is limited by dimensions of finished product and room available inside the formwork. Taking into account normally aggregate size depend on the following condition: 1/5 narrowest distance between the side of the formwork, 3/4 the clear spacing between reinforcement bar and between bars and the side of the form, 1/3 depth of the slab. Let's take in our case the maximum size of the aggregate is 19 mm. The next step in the concrete mix design is estimate of water and air. ACI recommend the following table for the amount of water per cubic yard of concrete as a function of desired slump. The top half of the table is for non-air entrant mixes and include an estimate of the amount of entrapped air in the concrete. The bottom half is for air entrant. It includes target air contents based on the expected severity of the freeze exposure. As we take the maximum size of concrete 19 mm, that is 3/4 inches. So from the table, the amount of entrapped air is estimated as 2%. For the desired slump of 1 to 2 inch, the required water content is estimated as 315 pound per cubic yard, that is 186 kg per cubic meter of cement. The next and the most important step is the water cement ratio. The water cement ratio is the convenient measurement whose values is well correlated with PCC strength and durability. In general, a lower water cement ratio produces stronger and more durable concrete. The ACI methods bases the water cement ratio selecting on desired compressive strength and then calculates the required cement content based on the selected water cement ratio. Table 4 is a general estimate of 28 days compressive strength versus water cement ratio. This table shows the water cement ratio and compressive strength relationship. So if our compressive strength after 28 days is 41.4 MPa, so we will take 0.4 water cement ratio. If the compressive strength is 34.5, we will take for non-air entrant 0.48 and for air entrant 0.40. So in our case, the compressive strength is 20.7 MPa, so we will take 0.59 water cement ratio. So friends, now we will find the cement content. Cement content is generally found from the water cement ratio and the water content. So we calculate both of them from the ACI tables. So the water cement ratio is 0.59 and water content is 186 kg per cubic meter. So the formula for cement content is cement content equal to water content divided by water cement ratio. If we calculate these 186 divided by 0.59, so the volume of cement will be 315 kg per cubic meter. The next step is weight of coarse aggregate. So ACI recommends the following percentage by unit volume of coarse aggregate based on nominal maximum aggregate size and the fine aggregate fineness modulus. So weight of coarse aggregate is equal to volume of coarse aggregate multiplied by dry rodded unit weight of coarse aggregate. For the weight of coarse aggregate, we will use table 9.4, that is bulk volume of coarse aggregate per volume of concrete. So in our case, we use the maximum size of aggregate is 19 mm, that is 3 by 4 inches, and the bulk density of coarse aggregate is from 1450 to 1750 kg per cubic meter. Let's we take this as 1600 kg per cubic meter. Normally we find the bulk density of the coarse aggregate from the lab, so you people use that, and the weight of coarse aggregate is equal to volume of coarse aggregate multiplied by dry unit weight of coarse aggregate. So the volume of coarse aggregate we will find from the table, that is for 19 mm, and the fineness modulus we take as 2.4. so the volume of coarse aggregate is 0.66. so if we multiply this 0.66 into 1600, this will come to 1056 kg. Now we will find the weight of fine aggregate. So the volume of fine aggregate is if we take volume of fine and coarse aggregate is 1. So in the previous table 9.4, we take the volume of coarse aggregate is 0.66. so 1 minus 0.66, that is equal to 0.34 cubic meter multiplied by 1600, that is, so the weight of fine aggregate is 544 kg. So friends, if we conclude all the calculations, so we have cement, volume of cement is 315 kg per cubic meter. So if we divide 315 by 315, so it will take 1 part of cement, and if we divide the value of fine aggregate and coarse aggregate, that is 544 and 1056 by 315. So for the value of fine aggregate will be 1.72, and the value of coarse aggregate is 3.35. so the ratio of our concrete max design will be 1:1.72 ratio or 3.35, which is approximately equal to 1:2:4. So friends, tell us in the comment section how you find today's video. Your feedback is valuable, and for more such videos, please subscribe to my YouTube channel and press the bell icon to stay updated. Thank you.